So an exponential function is any function where the x is in an exponent. And in the graphing calculator activity that you did over the last couple days, you got to see some of those graphs and what they look like. What we're going to be doing is we're going to be recognizing every single exponential graph with any base as a parent graph, and we're going to do all the transformations we did in Chapter 3 with our exponential graphs. Yay. So here they have the two types of exponential graphs. I'm going to actually do an example with each of them so that you can see it a little bit clearer. We have two types. We have one type where the base is bigger than 1. So for example, y equals 3 to the x. Now what you need to be able to do is you need to be able to quickly graph this. And when you graph this, there are two key points that you're going to put on there. First of all, every exponential graph, no matter what the base is, will always have the same y-intercept. Because when you plug in 0 for x, what happens when the exponent is 0? It's always equal to 1. The second point that you're going to have on an exponential graph is going to be related to the base. If I put in 1 for x, what would y be? It'd be 1, 3. I mean, you could put other points in. If I put in 2, I would have 2, 9, and so on. You could do more table values if you liked. But the key points will be that 0, 1, and 1, whatever your base is. The shape of an exponential graph looks like this, and there is always on the parent graph an asymptote at y equals 0. So this is one type of graph where your graph is increasing when your base is bigger than 1. The other one that we'll look at is what happens if you have a base between 0 and 1, like 1/5. Well, we go about graphing it exactly the same way. You know that it's going to have this point, 0, 1. Now when I plug in 1, I get 1, 1/5. And that point is below 0, 1. So the shape is the same, but this time it's going down. We still have an asymptote at y equals 0. If you played around with 1/5, if you used your exponent laws a little bit, would you agree that 1/5 could be written as 5 to the negative 1? Does that make sense? Because right now this is 5 to the 1 on the bottom of your fraction. You could use your negative exponent law and write it as 5 to the negative 1. The negative exponent law says that if you have a negative exponent, you could rewrite that on the other side of the fraction with a positive exponent. So 1 over 5 is same as 5 to the negative 1. And if I use my exponent laws here, that would be the same as 5 to the negative x. Now with transformations, what does that negative do when it's with the x? Flips over the y-axis. So can you think of a 5 to the x graph would look very similar to this 3 to the x graph on the left? And if you flipped it over the y-axis, would it not look like this? And I think there was a question like that on that assignment that you did the other day, to recognize that the 2 to the x graph was the same as the 1 over 2. 2 to the negative x graph, sorry, was the same as the 1 over 2 to the x graph. So we have two basic types of parent graphs, ones that are increasing and ones that are decreasing. And what happens in this unit, and what we didn't do, like when we did our transformations unit, we did the square root graph. We did the x cubed graph. We did the x squared graph. Those were basic graphs that you knew the parent graph. With exponential functions, there's thousands of parent graphs because the base can change. And then you have to be able to do transformations with each one. So we're going to do example one. Example one is just a straightforward parent graph here. And it has some questions to go with it. So we want to graph 1/3 to the x. Again, we know that it's going through 0, 1. And when I plug in 1, I'm going to get 1/3. Because the base is between 0 and 1, it's going to be decreasing. And of course, we have an asymptote at y equals 0. So now we can describe each of these things that they're asking us to give it some more detail. What happens to y each time we increase x by 1? Well, when we went from 0 to 1, y went from 1 to 1/3. If we would go from 1 to 2, if I plug in 2, I'm going to get 1/9. Right, so effect on y, as x increases by 1, you multiply the y value, and in this case it'd be by 1/3. Is this function increasing or decreasing? You can tell by going from left to right. This one is going down, so you would say that it's decreasing. Our intercepts, we have a y-intercept of 1. And because there's an asymptote on the x-axis, there are no x-intercepts. Equation of the asymptote, y equals 0. The domain of our function is everything, because you can put anything in for an exponent. There's no non-permissible values for an exponent. The range of the function, in this case, y is greater than 0, not equal to 0 because there is that asymptote there. So if you want some practice with parent functions, questions 3, 5, and 7.